When just starting off learning a Python module, you want to get in and start using it right away. So what's the fastest way to start using a Python module inside of Docker, inside of the Windows subsystem for Linux, if you're running on a Windows host? That's what we're going to find out today. We can start off by looking at the Docker images that are available on the host. There's a number here that we've downloaded over time, but the one we're interested in today is the Python 3.10 image. This image was created 7 months ago. That was when we downloaded it last. And if we go ahead and run which Python 3, then we'll be able to see that this particular executable is installed into user local bin. By running python 3 -- version, we can see that this is a Python 3.10.2 executable specifically. And we can go ahead and exit the container at this point. Now that we're back at our host command prompt, we're going to go ahead and run docker pull python :3.10. What this will do is it'll go out to the Docker Hub and download the latest version of this Python 3.10 image. If we go ahead and run that image again with bash, we can see by running python 3 -- version again that the version of the Python executable inside of that image has changed, and now we're running a Python 3.10.7 executable. All right, now that we know we have the latest version of the Python image and the latest Python available inside of it, we're going to pip install the requests library, pip install requests. The requests library is a great human accessible library for interacting with all sorts of websites and really just making any sort of HTTP request. Once we've installed it, we'll go ahead and run Python 3 to get our interactive prompt. We'll go ahead and import the requests module, and then we can start playing with it. So the first thing we're going to do is generate a request. So we're going to say requests.get, and in this case, we'll just use my website. But we forgot to save the object off into a variable that we can use in the future. So Python has this neat trick where you can refer to the output of the last command with an underscore. So we'll go ahead and do that and get the request object stored into a variable called r, just for a shorthand while we're playing around here. Once we have that object created, we'll go ahead and look at some of the attributes that are available to us. We can type r.statuscode to see what the status code response of that last request was. In this case, it was a status code 200. Since the headers attribute of the request object is just a dictionary, we can actually inspect and modify that dictionary as needed and actually use it on future requests. For example, you could actually use this for setting up the user credentials on a request if you had if you wanted to pre-compute those in advance and then use them in your request. And you can see that other attributes are placeholders. So the r.history attribute is an empty list. And then we can go ahead and run r.text, which is actually just going to dump out all of the HTTP response or the HTML response of the page that we requested. Once we're done exploring this object a little bit, we can go ahead and run exit to exit out of the Python interpreter. Now that we have some experience using the Python interpreter and the requests library to generate an HTTP request, let's go ahead and look at a better Python interpreter option, specifically talking about iPython 3. So what we're going to do is we're going to Docker run a new Python 3.10 image, and then since this is a brand new image, we don't have any of the packages we had before. So what we're going to do is we're going to pip install both requests, the library we needed to install before, and iPython, the new package we're going to start using. To launch the iPython interpreter, you can run iPython 3, and that will put you in something that looks a lot like a Python interpreter shell like we've been used to. From there, what you'll find is that iPython actually has some built-in shell support, so you can actually run commands like ls directly in the Python interpreter. However, some commands like whoami are not available. So let's go ahead and recreate what we did before. We'll import the requests library. We'll go ahead and make a request, and then we'll go ahead and, because we forgot to store it again, we'll go ahead and store that into a variable using that same r=_ that we did before. And now we can go ahead and do some other commands. So we're going to generate a new list object, and we're going to generate a new number object. But one of the coolest things about iPython is that it actually keeps track of all the output objects from the Python interpreter, and you can actually slice into that based on the index of the command that you ran. So in this case, if we wanted to go back to the fourth command that was run, we could access that with out open square bracket, for closing square bracket. And that corresponds to the same object as our requests object we generated earlier. And we can actually check that by comparing that R is equal to out for. Now that we have the basic building blocks, let's see if we can put these concepts together. Instead of simply looking at the GET request for a static HTML website, let's go ahead and look at something more dynamic. In this case, we're going to use the GitHub REST API, and we're actually going to look through the documentation. You can read through it if you want, but what we're going to focus on is we're going to see what information we can get out of the user's API specifically. Without having to do any authentication, you can actually get a fair amount of information out of the GitHub API, and so let's give that a shot. We'll start by copying the base part of the API URL out of the documentation, adding into our requests.get function call. And in this case, we'll just use my username, Ianly1521, as the user we're going to get information about. When we run this, we get a standard response back. We can store that in a variable again with r equals underscore, and then we can start looking at what attributes and information is available on this response object. The first thing we're going to do is look at the JSON blob that makes up the request. This is particularly useful for things like APIs where the responses tend to come back as JSON. And in this case, we can see a bunch of the different attributes that are returned by this API. And it's important to note that what you get back with the requests library is the same information you would get if you would just put this URL into your browser directly. After this, we can go ahead and look at the dictionary on that response object. This contains all of the methods, attributes, and other information about that object, and is a built-in attribute on all Python objects. It can be really useful in certain cases. When I'm writing a script, I use the history command a lot to see what commands I've been executing so that I can put those together into a script. In this case, we're going to write a quick little function in the interpreter. We're going to define a new function, get GitHub user. We'll pass in an argument of a username, and all that we're going to do is, for this particular function, is to make a GET request to the GitHub API using that username that's provided. We'll store that response object in a variable called R, and then what we'll do is we'll go ahead and print the output of calling the JSON method on our response object. Now what we're going to do is we're going to see if we can get these commands that we've run in the interactive terminal and turn those into a script in case we want to be able to use those again more frequently in the future. So we'll go ahead and run that same history command. That'll print out all the commands that we've been running in this session, and we can copy that onto our clipboard and paste that into the editor of our choice. In this case, I'm opening up the Visual Studio Code editor. We'll go ahead and paste that in. Visual Studio Code will actually detect that it's Python code and reformat it accordingly. And at this point, we can go through and kind of clean up some of the commands, remove things that we don't need anymore, and add some of our Python styling. And now we can go ahead and save our script. Although in this situation, we actually ended up launching Visual Studio Code on our local machine and not in the Windows Subsystem for Linux WSL session that we had been working in before. So what we'll do is we'll go ahead and we'll reload Visual Studio Code into the proper container that we were running our code in, where we had installed the requests and iPython modules. At this point, we can go ahead and save our script into the container. Then from the command line, we can execute python3 script.py, and that'll run the script that we just created. And this will give us the same output as what we saw when we ran this code in the interpreter. And there you have it. This is the process I would use for creating a script from some module that I'm not familiar with, working in the interpreter first, and then exporting the code that I ran and turning into a script from there, iterating as needed. Thank you for watching, and if you found this video helpful, please like and subscribe for more how-to and tech education videos.